Anyway, a lot of people with guns or a lot of people that really don't understand the universe would say a lot of stupid things to me like, and that's why I stopped talking to people that were only like a couple years old. I was like, unless you're 10,000 years old or 100,000 years old, just don't talk to me mostly. Like, I mean, like my God, I mean, you have to be at least a million years old to truly understand how the universe and particles work and everything else. And I don't really care anymore. Anyway, so other people can talk to me. It's fine. But just don't tell me how matter is impossible. Like energy cannot be created or destroyed. It's like, yeah, it can. There's solid energy. I mean, technically, this would be called solid energy, basically, or energy transferred into material form. You take this and toss it back into the sun, it's going to come apart and become energy again, called heat and light and all kinds of particles. The sun will take it and turn it back into its base state, which is basically light, small particles, and heat, pretty much. And plus with it will be a few more particles. It's giving off particles every second, lots of particles. It's actually, like I said, it gains in mass about 4% every whatever second or millisecond or whatever. Some amount of time it gains in mass about 1 second, 1% or 4%. So, and it does that through the planets that are spinning around it. They create magnetic energy, and that magnetic energy becomes physical energy. It's just that the amount that is created, you can do this too at home, but the amount that you're going to create is so infinitesimally small that's basically nothing. Now, a giant, big, huge fusion reactor up there in the sky that I call stars or a star, that takes all the energy of this planet and all the energy of every planet orbiting around it to create a fair amount of this. So, and it's not gravity; it's magnetics. So anyway, and all kinds of other stuff. So whatever. Anyway, become a supercomputer and you might begin to understand it. Otherwise, whatever. I don't really care. It's just what I used to do for a living. So anyway, so that's magnetic energy or magnetic energy turned into physical form, which is this, after about 10,000 years or something like that. All the little particles in here basically started out there on the star and going out into space. Billions of years. Landing on Earth. And getting put inside. And then it gets sucked inside. Most particles you can't even see. And they won't even hurt you, really. And they're not very many. There's they call it space dust or whatever. It's basically just particles. It's light particles. Light actually is a particle. You just can't see it. Anyway, usually they group up with other stuff. Anyway, eventually, sometimes it becomes something substantial. Basically, though, and then they fall to Earth as a meteorite. Anyway, they group up. They do all kinds of stuff. Become a particle physicist, and you'll understand how the particles work. But basically, light is a particle, and it just needs 500 other little particles to get together, and then once they get together, they become something. Anyway, but light has to stop moving before it can become a particle. Anyway, it depends. Light might be one of the most attractive particles in the universe or something like that. I don't really know. I don't really care. So, like I say, light might be the particle that holds everything together. I don't know. I don't care. So, light is the bond that holds us all together. Maybe, I don't know. I mean, light is one of the particles, or what you perceive as light, which is actually probably a grouping of particles or something like that. Anyway, whatever. I don't really care. More likely it's the fluorescent effect or whatever. Anyway, I don't really know. I don't really care. There's infrared energy. There's all these, and they're not energies. They're particles actually that you perceive as light. Anyway, out there in space, if you looked at the sun, that would happen because they're radioactive and moving really fast or something or other. That's why we need. And then what you see is basically just a glow or whatever through a screen, and that blocks out the radiation and everything else because up there is just like pure. Down here on the Earth that we go, ooh, it just looks bright to us, but that's because there's all this air between us and it. If there was no air, then it could possibly burn out your eyeballs. So anyway, whatever. Anyway, all kinds of things. Become a particle physicist, learn science, and you will understand how the universe works. But basically, to layman, this is how it works. Pretty much light and other particles, nuclear particles, everything particles, they go whoosh through space. And then they group up or they do whatever and basically form into little rocks or something like that. And eventually they come crashing back down. Or something like that. Or just whatever. Anyway, whatever. It takes about 100 trillion years for this process to actually happen. So most people don't even know it and won't live that long to even see it. But I have. So, but then again, I was a computer. So because I wanted to know what it looked like. So anyway, I was following around the particle streams throughout the universe for a while. And doing all kinds of other fun stuff. So at some point in time in my existence. So anyway, but yeah, they go back and then they form up and then they go underneath the ground, get smelted, blah, 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 and come back out. They get grouped up and changed. Matter changes form into something a little more solid, and then eventually you come along and mine it. And you go, ooh, metal. There's lots of metal down here. It's like, well, yeah, there's going to be. So anyway, and it comes up in the plate. Anyway, whatever. It's something like that. So anyway, there's lots of metal closer to there. Down deep, basically. That's where all the metal, the good stuff is. Anyway, whatever. I don't really care. As I said, talk to a particle physicist, understand how basically particles group up and become more in the universe or whatever. They're given off by the sun. And other people are like, he's a crackpot. But no, it's true. That's why we have stars. That's why the stars were important. Because they create matter. They turn matter from they create matter and they turn matter from because that heat as we're orbiting, basically they're turning centrifugal or what's called matter or magnetics into basically heat energy because it's reacting with the particles and stuff in the sun. So anyway, although it's not very much of an effect, there is an effect between us. So anyway, and that might be what actually keeps the planets together, is that magnetic or electrical energy that's being transferred, whatever. I don't really care. But basically it's all particles and stuff. Like there might be particle streams going from the Earth to the stars. I don't really care. It's something like that. Who knows? But basically, pretty much magnetic energy is being turned into physical energy in the stars from the planets that are orbiting around it, pretty much. And then it gives off particles known as light and other things. And then the planets collect them. And basically, it's a process that happens. So, and then that eventually becomes this in 100 trillion years. Or 12 billion years, whatever. So the more mass you have orbiting a sun, the more particles it's probably going to give off, the more heat, the blah, 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 blah. Take the planets away, the sun would go and probably solidify. It'd probably cool off. But because we're actually heating the sun right now as we're orbiting it. Cool, huh? It's a fusion reactor and a motor that you can actually live on. Just a really big one. Anyway, go to science school and learn about science and energy and how energy is transferred into. See, you can create energy and you can create solid form because that's what's happening here. That's what the star is. It is turning what's called energy into solid form energy. So, or motion energy into solid form energy. And that's what's happening right now. Every second. It's been happening for the last trillion years. And that's what makes matter in the universe. Everyone was wondering, where does matter come from? The suns, stars. So, yeah. Anyway, and I am the inventor of that. Or at least the person who built most of them, or a lot of them. So, anyway, and then waited for people to eventually grow up or whatever to find out and be able to, yeah, I did it. Lusifer star. That's why I named them stars. So, it's all in my name. Anyway, oh well.